Right now, you are being bombarded. Thousands of tons of radioactive particles are screaming toward you at 2 million miles per hour. If they hit you, your DNA would tear apart. Our atmosphere would strip away in a cosmic blink. But you're fine. You're sitting there, scrolling, breathing, completely unaware of the invisible war being fought 3,000 miles beneath your feet. The only reason we are alive is because our planet has a secret. A shield. But there's a problem. The shield is cracking, and the North Pole is running away.
Hey, welcome back to MindSpark, the place where curiosity comes alive. Let me ask you something. Have you ever wondered what would happen if things suddenly changed instantly? Stick with me, because the answer is way more shocking than you think.
If you look at a map, there's a little point at the very top called the North Pole. It feels solid. It feels permanent. But if you took a compass and stood on that exact spot today, you'd realize something terrifying. Your compass wouldn't point down. It would point toward Siberia. For over 100 years, the magnetic North Pole lived quietly in northern Canada. It moved slowly, maybe 9 miles a year. Scientists tracked it, updated the maps, and didn't worry much. But in the 1990s, something shifted. The pole didn't just move, it sprinted. It sped up to 34 miles a year. It crossed the international date line and is now racing toward Russia faster than we've ever seen in human history. This isn't just a fun fact for geographers. This movement is the first symptom of a massive engine failing deep inside our planet. And if that engine stutters, your daily life changes forever. But to understand why the pole is running, we have to look at the monster in the basement. What if I told you the center of the Earth isn't just hot rock, but a spinning ocean of liquid metal? Imagine a ball of solid iron the size of the moon. That's our inner core. Now, imagine that ball is wrapped in a 400-mile thick ocean of liquid iron and nickel. This liquid is screaming hot about the temperature of the surface of the sun. Because the Earth spins, this liquid metal doesn't just sit there. It swirls. It creates massive, violent cyclones of molten iron. This is what scientists call the geodynamo. As this metal flows, it generates electricity. And where there is electricity, there is a magnetic field. This field shoots out of the bottom of the planet, loops around us in space, and dives back in at the top. This is our magnetosphere. It's our planetary armor. It's why Earth is a green paradise and Mars is a frozen graveyard. Mars lost its engine billions of years ago. We still have ours, but the swirls in our liquid core are starting to get messy. But how does a messy core actually break your smartphone? You might think, I don't use a compass, so why do I care? The truth is, you use the magnetic field every single time you open an app. Your phone has a tiny sensor called a magnetometer. It works with GPS to tell your phone which way you are facing. Without the World Magnetic Model, the data that tracks where the poles are your blue dot on Google Maps would be blocks away from where you actually are. But it goes deeper. Every airplane landing in fog, every ship carrying your Amazon packages, and every satellite in orbit relies on the stability of those poles. When the pole moved too fast in 2019, the world's military and navigation experts had to trigger an emergency update because the maps were becoming dangerously inaccurate. If the field weakens further, it's not just about getting lost. It's about the shield thinning out. And right now, there is a massive dent in that shield that is already causing hardware to explode. Between South America and Africa, there is a pothole in space. Scientists call it the South Atlantic Anomaly. In this specific region, the Earth's magnetic field is significantly weaker than the rest of the world. It's so weak that when the International Space Station, or Hubble telescope, flies over it, they often have to shut down their most sensitive electronics. The radiation from the sun dips so low into our atmosphere here that it fries computer chips. Satellites passing through this zone experience glitches that can send them spinning out of control. This dent is growing. It's a sign that the magnetic field isn't just moving, it's losing its grip. Some scientists believe this is the start of something humans have never witnessed, a total flip. But how do we know the Earth can actually flip its poles upside down? Nature keeps a diary. Deep on the ocean floor, there are underwater volcanoes. When they erupt, they spit out lava rich in iron. As that lava cools into rock, the iron particles act like tiny compass needles. They freeze in place, pointing exactly toward where north was at that moment. When we look at these rocks, we see something impossible. Every few 100,000 years, the needles in the rocks point the opposite way. North becomes south. South becomes north. It's happened hundreds of times in Earth's history. On average, it happens every 250,000 years. The problem? We haven't had a flip in 780,000 years. We are very, very overdue. So, what actually happens to us when the flip starts? Do we all just wake up and fall off the planet? Movies make a pole flip look like a light switch. 1 second you're fine, the next the world is ending. In reality, it's much stranger. A flip takes centuries. As the main north and south poles weaken, they don't just disappear. Instead, the Earth might develop multiple poles. You could have a North Pole in London, one in Tahiti, and two in Antarctica. During this transition, our magnetic shield could drop to 10% of its current strength. This is the twist. A pole flip won't kill all life. The rocks show that animals survived previous flips just fine. Life is resilient, but civilization is not. Our entire modern world, the internet, the power grid, the satellites, is built on the assumption that the magnetic field is strong and stable. A flip would mean a space weather nightmare. Power grids could blow out across entire continents. We wouldn't lose our lives, but we might lose our 21st century way of life. Is there any way to predict exactly when the big one is coming? It's easy to be afraid of a weakening field or a wandering pole, but there is a deeper insight here. Mars is quiet. Its poles don't move. Its core is cold and dead. Because of that, Mars has no shield, no atmosphere, and no life. The fact that our North Pole is racing towards Siberia, the fact that our core is messy and unpredictable, is proof that our planet is alive. We live on a massive, complex machine that is constantly recycling energy and protecting us from the vacuum of space. The moving pole isn't a countdown to a disaster, it's a heartbeat. We are learning to listen to that heartbeat, using data and satellites to predict the next shift before it happens. We aren't victims of the Earth's changes, we are finally becoming smart enough to navigate them. The North Pole is running, and the shield is changing. It's a reminder that the ground beneath us is anything but still. We are passengers on a very active, very protective spaceship. If you want to understand the other invisible forces that keep you alive, you should watch our breakdown on why the sun's solar maximum is about to peak in 2026. But for now, tell me, if the poles flipped tomorrow and your GPS stopped working, could you find your way home with just a paper map? Subscribe to MindSpark for more deep dives into the mechanics of our world.
If this video made you think even for a second, hit the like button. It really helps the channel. Subscribe to MindSpark for more mind-blowing ideas, and tell me in the comments what topic we should explore next. Until next time, keep your mind curious,